Good morning, friends. I am Dr. More from Bharati Vidyapit's Institute of Management and Entrepreneurship Development MCA program. Today, I am going to discuss with you about rough shades, classification theory in data mining. Our lecture is about rough shade. We are going to start with the introduction of rough shades, the theory of rough shade, how it is evolved, what are the major issues, why this particular theory is required, what are the problems this particular theory addresses. All these things is the part of our agenda today. Friends, rough set theory was first introduced by Jadlock Pollock in early 1980s. This particular theory was introduced as a classification theory by Mr. Pollock, and it was unnoticed for a long period, almost for a decade or more than that. In 1996, some of the researchers again took interest into this particular theory, and they have identified that this particular theory is very much useful in classification problem, in addressing the various classification problems. The theoretical aspects and all this about rough shade was published by Pollock first. Now we are going to see what are the issues in this particular world so that this particular theory can be used. As you know that in today's world, huge amount of data has been generated because of automation. Many companies and organizations, they are doing their business on internet as well as various different IT products, and these transactions which are happening in the world, they are creating amount of data which is generated in and which is growing in all with very high speed, and this particular data is required to be classified properly. The other problem in the real world is that the data which is available is in the mixed type. The data coming from various sources is organized and saved in the type which is convenient to the user from that perspective. The third important thing is about data is uncertainty. The data which is coming, which is not in a certain format, and that is the issue in the with the data. Data is coming in the incomplete format. Some of the data which is missing in real world data entry, and the change. The data format is also changing again and again. The most important thing is that whenever we are going to use the classification problem, we need to have the use of the background of that particular domain, which is essentially not available every time. So these are the issues in the real world, and we are trying to see that how a rough set theory can be used to address this particular problem. The goal of rough set theory analysis is as follows. The first and the most important is the induction of approximation, the concept of approximation, which we are going to discuss in this lecture. How rough set theory has introduced the concept of lower approximation, upper approximation, and the other part. Rough set theory constitutes a sound basis for knowledge discovery through databases. This term KDD stands for knowledge discovery from the databases. It offers a mathematical tool to discover patterns which are hidden in the dataset. It can be used for feature selection, feature extraction, data reduction, decision rule generation, and pattern extraction. These are some of the contributions or the goals of rough set theory in classification problem. Next. The concepts which we are going to discuss today is information and a decision system, the indiscernibility relationships, set of approximation, the important point that is reduct and core, rough membership, dependency of attributes, and finally the decision rules. These are the concepts we are going to discuss. First, let us start with the data set and the information system. Information system is a data set which is represented in the form of information system, where there are finite non-empty sets of objects which are denoted by U and finite non-empty sets of attributes in such a way that every attribute has certain values. A decision system A is a special kind of information system used in the context of classification where the D is a decision attribute. The example of set of approximation. Now let us see the table which is visible on the screen, where there are 8 objects and every object is represented or described by 3 different attributes. This particular data is about the cars, and these cars are finally classified into 2 different types, that is good car and a bad car. The attributes which are used to describe a car are basically 3 attributes: engine, the size and the color. So these are the 3 values for the these are the 3 attributes available for the description of the car. But within that, if you see that every engine is described by 4 different values. Engine may be of propane type, it may be of diesel type, or it may be of gasoline type. Similarly, size has 3 values: compact, medium and full. And the color is having 5 values like black, white, red, gold and silver. And finally, as you know, that decision attribute is defined with 2 values, that is good car and a bad car. Here this set of 3 attributes, that is engine, size and color, is called as a condition attributes or condition variables, while final attribute D is called as a decision attribute. Now looking at this, there are the issues in the decision table. Normally, when a decision table is prepared or the information system is prepared, it happens that the same or indistinguishable object may be represented several times. Since data is generated again and again, it is very much possible that some of the objects may get repeated again and again. Some of the attributes may be superfluous, that is redundant. They are not going to add any typical or additional information, or they are not going to be useful in the classification. They may be redundant. These attributes, even if you remove these attributes from the table, there will not be any major or substantial change in the output of that particular analysis. And finally, the most important is that even if you remove, they will not worsen the classification of the database. Here we are going to start with the indiscernibility relationship. Now, what is indiscernible relationship? Now, when you compare 2 objects with each other with respect to certain attributes, and when these attributes are taken into consideration for comparison of 2 entities or objects, we cannot separate out these objects from each other for the considered attributes which are under consideration. Now, these type of objects are called as a indiscernible objects. That is, the objects or a group of objects which cannot be separated from each other by considering certain attributes. Means we can say that the values of these attributes for these objects are same, and that is why they belong to the same group, or that is why we cannot separate out them from for this particular attribute. These are called as indiscernible. Now, for example, let us see how this indiscernibility relationship exists in the previous table. Again, you can see on the screen, we are considering first attribute, that is engine. By considering engine as an object, we are trying to compare all the objects. And if you see that the first object class, that is x1, has only one object, that is the x1 object, because there is only one car with the type engine is propane. The type of engine is propane. There is another class, that is x2, where the 3 objects are existing, that is x2, x3 and x4. For all these 3 objects, the value of engine is same, that is diesel. Then the third group is of type engine gasoline, where object x5, x6, x7 and x6 are there. So if you see that for this particular table, we could able to identify three different classes for the attribute engine, where three types of values are existing: propane type engines, the gasoline type engines and the diesel type engine. There is a concept of approximation, which is a lower approximation, upper approximation, and a boundary. Now, normally let us take an example of a real life word. See, when you are trying to approximate certain group, then that time you have to identify which are certain, which are non-certain. For example, let us take example in a election campaign. Suppose assume that there are two parties, A and B. There are certain followers of party A as well as certain followers of party B. That certainly belongs to that party, irrespective of the particular contemporary issues and all these things. They will not make any difference on the what do I say loyalty of that particular voter. They will certainly belong to that particular party. There are certain people, those who are certainly does not belong to that particular party, or they are not the voters of the party. Now, but apart from these two groups, there are certain groups or majority of the group which are on the boundary, which are not certain. They are not loyal to party A as well as they are not loyal to party B. They will take their decisions depending upon the contemporary issues which are arising in that particular election campaign. And these are the voters which are calling them as the boundary region. So same is the case with the classification of the any particular data. The lower approximation region is a positive region, belongs to certainly belongs to that particular group. The upper approximation is a probable, they are certain as well as all those who are in boundary, they are considered as a upper approximation. The difference between upper approximation and the lower approximation, we are calling it as a boundary. They are not certain region. And those who are not part of this particular, there are the negative regions, objects of negative region. This particular diagram shows you the inner square, which shows you the lower approximation, while the yellow square shows you the upper approximation. And the circle within that red circle, which is a boundary which we are trying to find out that which are the elements which are on the boundary. That is the difference between these two. How we are going to identify, how we are going to classify them, which are in the boundary region. Now, from this set of approximation, let us come to our example of engine. By considering the concept of decision, good, let us consider that. Let us take the attribute engine. For now, we are going to concentrate only on the cars which are good, and we will consider the attribute engine. Now, by considering this, we have got the first group, that is X1, X5 and X6. What is common in all these? All these cars are classified as a good by the expert. Now, what is the upper approximation? When you consider engine as an attribute, as far as propane is concerned, that is the only object, there is only single object having propane engine. But if you consider gasoline, there are four objects, out of which two are considered as a good and two are considered as a bad. But when you consider the upper approximation, you have to consider all the objects having the same value for the type engine, for the attribute engine. So by considering this, our approximation will contain object x1 as well as x5, x6, x7 and x8. We are adding x7 and x8 also, even though they are bad, because they have the same value of engine, that is gasoline, as we are considering for the which is under our consideration. Now, as per our rule, the difference between the upper approximation and the lower approximation is called as a boundary. And for this particular sake, we are getting x1, that is the only object which is which is under the lower approximation. Which is under the lower approximation. But as far as the boundary is concerned, the difference between upper approximation and the lower approximation is the boundary. So subtracting the lower approximation from the upper approximation, we get the boundary region. And the objects in this boundary region are x5, x6, x7 and x8. So we can say that from this, the universe minus upper approximation, that is x2, x3 and x4, they are the objects which are in the negative region, which are not under consideration. The decision class good is rough since the boundary region is not empty, because the boundary region has four different objects. It is not an empty region. Accuracy. Accuracy of the approximation. The accuracy of the approximation is calculated by a formula which that is cardinality of the lower approximation divided by cardinality of the upper approximation, where cardinality denotes the that is which is not equal to 0, and that means it is obvious that when we talk about the approximation, accuracy of the approximation, it will lie between 0 to 1. If it is 1, we can say that it is a crisp. There is no ambiguity. It is very clear-cut classification. But when it is less than 1 and greater than 0, it means that there is a rough area existing in that particular data set. Redux. This is one of the important concepts in rough shades. Reduct, we can say that keeping only those attributes that preserve the indiscriminate relation and consequently the set of approximation. There are usually several such subset of attributes, and those which are minimal are called as reducts. In simple way, we can say that when we consider the objects from a data set or from an information system, if we consider certain attributes to classify the data, and if we get the same type of classification by considering a subset of attributes, and if we still preserve the original indiscriminate relationship of the data set, we can call it as a reduct. There are number of reducts we can find for a particular data set. Ultimately, objective reduct is that when we are able to find out the reducts, that is, ultimately we are saying that we are identifying minimum attributes from that particular information system in such a way that the classification power of that information system will not be compromised. That will retain, that will remain. That is the advantage of identifying the reducts. When there are several reducts available here, when we consider when we identify multiple reducts from the data set, the intersection of all these reducts, we call it as a core. Ultimately, it means that these are the attributes which are the most crucial attributes of that particular information system for the classification problem. We cannot avoid or we cannot neglect these attributes from our information system. Now let us see another example. Here this example is showing you a data set of patients which are suffering for which we can say the suspects of a disease called as flu, and there are three different attributes taken into consideration. First one is headache, second one is muscular pain, and third one is temperature. And based on these three attributes, by studying these three attributes, we are going to classify the patient as whether he is suffering from flu or whether he is free from flu. If you see the original data set, all these three attributes are taken into consideration. And if we see that, we are getting several equivalence classes for that particular 6 different equivalence classes. By removing one of the attribute, we will see that can we get the same type of equivalence classes. Now here in the second table, we have seen that only two objects or two attributes are taken into consideration, that is muscular pain and temperature. In this case, we have removed headache, and by removing headache, we got 4 different equivalence classes, which is not exactly same as the original one. So we can say that headache cannot be removed from the set of attributes. It is one of the important attributes. But if you consider the another table where headache and temperature are taken and muscular pain is removed, in that case we are getting the same equivalence classes. So we can say that muscular pain is not an important attribute which can be considered for the information system. We can easily remove that, or we can easily discard that particular attribute, and still we can get the same equivalence classes. And that is what we are going to identify. But getting this particular thing, getting this particular data or attributes or finding out the leader is not an easy problem. In computer science, there are certain problems which are called as NP-hard problems, and this type of problems are these type of problems of identifying reduct and core are NP-hard problems. So here, there is a concept of discernibility matrix. What this discernibility matrix does, it compares every object of that particular information system with the other objects of that information system. And in this comparison, it creates a matrix, and every cell of matrix represents the comparison of one object with the other, and it only stores those attributes where these two objects are differ from each other. Now, by considering this, we can create the by using this. When we get this particular matrix ready, we can count which attribute is frequently occurring in this information in this discernibility matrix. If this particular object, if this particular attribute is repeating again and again and having more count as we have defined the threshold value, if it is more than the threshold, then we can consider that object as an important attribute in that particular information system. So by this way, we can identify the reducts from the information system. Now, ultimately, our goal is to generate the decision rules. Now, again coming back to our problem of cars, we are having two classes, good and bad car. Good car is denoted by Y1 and bad cars are Y2. These concepts, if you consider, there are three good cars in this information system, and there are five bad cars in this information system. By considering engine and size, we are trying to make the rules. By considering engine and size, we have created the equivalence classes for both these. So where engine and size, if you consider engine is propane and size is compact, those cars are good cars. And when the engine is diesel and the size is medium, those are the bad cars. The equivalence classes shown over here shows that the engine and size has equivalence classes like X1, first class content X1. Similarly, there are other classes 1, 2, 3, 4, 5. 5, 6 different equivalence classes are created here. Now, what are the rules we can generate from this? We can say, whatever rules we have identified by having these equivalence classes and by having the intersection of the concept as well as the equivalence classes, the rules generated here are: if the engine is propane, we are certainly calling it as a good engine. If the engine is gasoline, that is also a good engine. If the engine is gasoline, we are calling it as a good engine. And from this rule, this type of rules, we can say that there are certain deterministic rules and certain undeterministic rules. That is the rule which is certain, that is the rule number 11, L11, that is engine is propane and car is good. That is a deterministic type of rule. While the rule L14, that is engine is gasoline and still it is a good, that is a non-deterministic, because we know that there are certain cars which are having gasoline as the engine but they are not good. That is why it is a non-deterministic. While L15 is a deterministic rule. That is, this is the way we can create. So applications of rough set theory is the final discussion of our topic. Rough set theory is used in many different areas, in very different domains. In medicine also it is used. This very common examples of rough set theory in medicine is the treatment of duodenal ulcer, which that is HSV, the diagnosis of pneumonia patients, as well as the preterm birth prediction can be done by using a rough set theory. In economics, business, and finance, It is used for identifying the bank credit policy, customer purchasing behavior patterns, the discovery of strong predictive rules of stock market. These can be identified by rough set theory. In environment science also, drawing up the pre-minority factors of the earthquake by emphasizing the gas geochemistry, global temperature stability, programming water supply system. These can be addressed by rough set theory. In engineering also, filtration and coding of audio, assessment of concert hall, acoustics, image analysis. These are the applications of rough set in engineering. In all, rough set theory and data mining applications are used in various sectors: telecommunication, security, science, retail, pharma, manufacturing, investment, insurance, fraud detection, and entertainment. So, this way, we are going to, this is the overall description of rough set theory and application of rough set theory in data mining. Rough set theory, as we discussed, is one of the very powerful classification theory. If it is combined with other traditional theories like neural network, genetic algorithm, fuzzy sets, we can have the hybrid model of classification. And definitely, the theory which is been many people are working on this particular theory has proven its importance in the domain of classification. Thank you very much.